Okay, so today we are going to start our new topic of algebra, that is polynomial expressions. So our next topic is that is polynomial. Okay, now first let us define the term. What is the meaning of the term polynomial? Okay, basically this term mainly consists of two terms. Okay, this expression can be divided like this. One first term is poly. Now how can we define this term? This term means many. Okay, means poly means many. And what about the nomials? We can define the term nomials is number of terms. Okay, so we can write number of terms. Okay, so polynomial expression is an algebraic expression which consists of many number of terms. Means if in any expression the number of terms are more than uh, if in any expression the number of terms are large, then the expression is known as the polynomial expression. Now we come to our next, that is the general expression of the polynomials. Okay, so our next topic is that is general expression. General expression of polynomials. Okay, now let us define what is the general expression for the polynomials. We can define in such a manner: if any polynomial expression is defined in variable x, then it can be written as p of x. It can be written as p of x, or we can say it is the function of any variable x. Now how can we write the expression? If the terms are a0 plus a1x plus next term is a2 x square up to so on, and finally the last term is an x to power n. This is the general expression for a polynomial. Now in this expression, what can we say? In this expression we can say, if in this expression two things are involved. One is x. X is the variable. What about the x? X is the variable. Okay, and now what about the a0, a1, a2, a3? About all these we can say these all are where a0, a1, okay, next a2, and so on. These up to an, these all are the real constant. Means this can take the values real. These all are the real constant. Okay, now we come to the next expression, next term, that is regarding to polynomial expression, that is the degree of the polynomial. Okay, so how can we define the degree of the polynomial expression? Okay, so our next topic is degree of the polynomial expression. Okay, degree of polynomial. Okay, how can we define the degree of the polynomial? We can define the degree of the polynomial in such a manner. Degree of the polynomial means it is the highest power of the variable in which the polynomial expression is defined. Means here the polynomial expression is defined in variable x. Now the highest power of x is defined as the degree of the polynomial. So we can write it is the highest power. It is the highest power of it is the highest power of variable. It is the highest power of the variable in which it is in which the expression is defined. In which the expression is defined. Okay, here the highest power of x is n. So degree. Here we can say degree is equal to n. But the important condition is that coefficient of highest power should not equal to 0. Then only we can say the degree of the expression will be is equal to n. Okay, now next we come to our next term. Okay, what are the different values which n can take? Here we can write values of n belongs to whole numbers. Values of n belongs to whole numbers means n can take the values whole numbers. Whole numbers. Now what are the whole numbers? Means values of n can be 0, 1, 2, 3, and so on. These all are the values of the n. Okay, means degree cannot be negative, degree cannot be in fraction, degree is always a whole number. Okay, now let us solve some questions. Okay, so our first question is, okay, which of the following are the polynomials? Which of the following polynomial? Okay, we are writing some expressions and we have to tell which of the following are the polynomials or not. Okay, so our first expression is, that is square root of 3x square plus 2x plus 5. Okay, then we write down the second, that is x plus 1 by x. Then we write down the third one. We can write, this expression can be written as x square plus 2x plus x divided by x. We can write one more example here. If 2x square plus 5, then we come to our next example, square root of x plus 1 by x, square root of 3, next question is 0. Okay, these all are the questions in which we have to identify each and every expression and we have to tell which of the following expressions are polynomial expression or not. Now let us check one by one each and every one expression. Okay, first of all we come to our first expression. Now how can we check any expression is a polynomial expression or not? First of all, we have to look for the two primary things. One, the power of the variable in which the variable is defined. It should be a whole number. Okay, and there should be a variable and constant. Means in this expression, in the first expression, okay, if you look at the powers of the variable, for x raised to power 2, 2 is a whole number, x raised to power 1 is a whole number. Okay, except variable x, all things which are involved in this expression are the real constant. Means in this expression, square root of 3, 2 and 5, these all are the real constants and we have already defined in our general definition then that the constants can be real constant, but the power must be a whole number, means this expression is a polynomial. Okay, now we come to the second expression here. If we simplify this expression, it can be written as x plus x raised to power minus 1. Now minus 1 is not a whole number, so that's why this expression is not a polynomial. It is not a polynomial expression. Okay, we come to the third expression. Okay, in this expression, if you simplify this expression, it can be written as x is common from all the terms from the numerator and the terms inside the bracket x plus 2 plus 1 all divided by x. Now x gets cancelled out. Okay, so what terms remain, that is x plus 3. Now in this expression, x raised to power 1, which is a whole number, means it is again a polynomial expression. Now we come to the next one. In this expression, we can simply say x raised to power 2, which is a whole number, means it is a polynomial expression. In this expression, here power of x is not a whole number, that is fraction, polynomial. Now we come to this example. It is also very important example. Square root of 3. Okay, but in this expression, we can say that x raised to power 0. Okay, now degree of x raised to power x is 0, which is a whole number, and root 3 is a constant, means it is again a polynomial expression. In this example, the 0 is a constant and constant can be a polynomial, means this expression is also a polynomial. So by checking, by observing the power of x, we can say that any expression is a polynomial or not. Now let us move. We come to our next topic, that is classification of the polynomial expression. How can we classify the polynomial expression? Let us come. Classification. Polynomial expression. Okay. Now how can we classify the polynomial expressions? Basically, we can classify the polynomial expression on the basis of mainly two criteria. Okay, what are the different two criteria? Let's define. We can classify the polynomial expression on the basis of two criteria. One, first we can classify it on the basis of number of terms. number of terms. Okay, and in the second way, we can classify the polynomial expression on the basis of degree. Okay, now how can we define this expression on these two bases? First, let us come to the summary on basis of number of terms. Now, on the basis of number of terms, we can classify the polynomial expression in like this manner. Now, first type of polynomial expression of polynomial, that is monomial. Monomial means any expression if number of terms, here we can write if number of terms is equals to 1, then the expression is simply a monomial expression. Okay, now what are the examples? Okay, these are the examples of the monomial expression. These x, okay, 2, okay, or xyz, okay, etc. These all are the examples of the monomial expressions. Now let us come to our next classification, that is binomial expression. Okay, what are the binomial expressions? If number of terms, means simply we can say if number of terms is equals to 2, then the expression is a binomial expression. Now what are the example of the binomial expression? You can say, okay, number of terms should be equal to 2, x plus 2, x raised to power 100 plus x, okay, 3 x plus 2. These all are the examples of the binomial expressions. Okay, we can say these all are the examples of the binomial expression. Now let us come to next type of classification we can see, that is trinomial. Okay, now what are the trinomial? Means if number of terms in the expression is equals to 3, then the expression is the trinomial expression. Okay, now in this expression what are the examples? We can see the more examples. Okay, the first example is trinomial, means number of terms should be equal to 3. So we can form the examples like this: x square plus 2x plus 5 is an example of trinomial. We come to the more examples, that is x raised to power 15 plus 2x square plus 2. It is also example of trinomial. Okay, etc. Okay, now further we can say if number of terms in the expression is more than 3, then the if we can write if number of terms in the expression is more than 3, then the name for the expression simply be a polynomial expression. Then such type of expression will be simply a polynomial. Okay, there is no any particular name for these all expressions. They will be simply called as the polynomial expressions. Okay, now we come to our next classification on the basis of number of on the degree of the expression. How can we define the expressions on the basis of degree of the expression? Let us come to one by one. Okay, on the basis of degree, first type of classification, that is constant polynomial. That is constant polynomial. Now, what are the constant polynomial? If degree of the expression is equals to 0. If degree of the expression is equal to 0, then the expressions are called as the constant polynomial. What are the examples of the constant polynomial? We can simply write any constant, for example 5, okay, square root of 3. These all are the examples of the constant polynomials. Okay, next type of classification, it is after constant we come to our next type of classification, that is linear polynomials. Now what are the linear polynomials? We can write about the linear polynomials. If the degree of the expression is equals to 1, then it will comes into the category of linear polynomial. Means we can simply write if degree is equals to 1, then the expression is a linear polynomial. Okay, and we can write the general expression for linear polynomial. If it is defined in variable x, then p of x can be written as ax plus b. where a should not equals to 0. That is the general expression for linear polynomials. Okay, if to look at the examples, what are the examples for linear polynomial? Simply any expression in which the degree is 1 equals 2 is the example of linear polynomial expression. Now we come to next classification, that is quadratic polynomial. So next is quadratic polynomial. Now what are the quadratic polynomial? In this expression we can say if degree is equals to 2, then the expression is simply a quadratic polynomial. Okay, and what is the general expression for the quadratic polynomial? We can write simply, if you want to write the general expression, you can write, if it is defined in variable x, then p of x is equals to ax square plus bx plus c, and condition is coefficient of x square should not equals to 0. And what are the examples? We can say any expression in which the degree of the variable is 2 is comes into the category of quadratic polynomial. Okay, so we can write an example. For example, x square plus 5. Okay, we come to the further classification on later on.